Hello and welcome to another NGen Math 7 lesson by eMathInstruction. My name is Kirk Weiler, and today we're going to be doing Unit 2, Lesson 7 on subtraction and distance. This is an important topic, all right? It gets only a little bit of coverage in Math 7, although we're going to be seeing it again and again as you move throughout mathematics. But there's a connection between the operation of subtracting two numbers and the distance those two numbers are from each other on a number line. And of course, in the real world, it's important many times for us to know how far two objects are away from each other, and one of the ways that we can do that is by sort of orienting them on a number line. So let's jump right into it in exercise 1 and start to understand how subtraction and distance relate to one another. Let's take a look. All right, exercise number 1. On the number line below, points are plotted at 5 and 16, all right? So I've got that number line, right? We've got a point at 5, we've got a point at 16, and just to be very clear about it, right, the distance between these points is simply the positive length between the 2 points on the number line, where of course, right, 1 unit on the number line is considered 1 inch or 1 centimeter or 1 foot, 1 mile, whatever the distance units are. So let's take a look at letter A, right, which doesn't have much yet to do with distance. Letter A simply says, evaluate each of the following, 16 minus 5 and 5 minus 16. All right, so obviously we've been working quite a bit in, signed number work with addition, subtraction, etc. What I'd like you to do is just pause the video right now and figure out what the answers to those two are. All right, well, 16 minus 5 is a piece of cake. That is, of course, just 11. And 5 minus 16, as you might recall, really should be the opposite of 16 minus 5. It's negative 11. All right, so easy enough. 16 minus 5 is 11. 5 minus 16 is negative 11. And again, remember, you can think about 5 minus 16 as being sort of the opposite of 16 minus 5. You can think about it as 5 plus negative 16. You can think about it as being 5 on the number line and moving 16 units to the left. Where would we be? We'd be at negative 11, right? So there's lots of different ways to sort of think about this versus this. Now, letter B, what is the distance between these 2 points on the number line? Well, let's just do this one together. Literally, if I just count, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So the distance between those two numbers on the number line is 11 units, right? Now, no great surprise, that kind of corresponds to the two numbers that we have right there. Well, it corresponds to this number, but not so much this number, right? And then that gets us into letter C. Let's take a look at letter C. How could we ensure that subtraction will give us the distance no matter which order we perform the subtraction in? All right, so let's talk about this, because what we'd really like, let's be honest, is we'd like a formula, right? We'd like to be able to say, hey, if I want to find the distance between two numbers on a number line, then I'm just going to subtract the two. I'm just going to find their difference. But the problem is, in one direction, that distance is going to, that subtraction is going to give us a positive number. And in the other situation, that subtraction is going to give us exactly the same number, except it's opposite, it's negative. So how do we ensure that when we subtract two numbers, how can we do one additional thing to make sure that the result ends up being positive? Think about that for a minute. Well, what we would do is we would take the absolute value. You remember that idea? We would find the absolute value of the result of the difference. So we simply need to find the absolute value. Whoops, come on you. There we go. The absolute value of the difference, right? Remember that absolute value, right, is those bars. And of course, the reason that works, if you remember about absolute value, is an absolute value just gives us the size of a number, right? How big it is, right? And it takes a positive number and it just gives you the value of that positive number. And it takes a negative number and it essentially turns it positive. So the absolute value of 11 is 11. And the absolute value of negative 11 is also 11. Okay? So the absolute value is just sort of the overall size of the number. And the great thing about that is as long as we take a difference, either direction, right, and then find the absolute value, the positive version of it, that will tell us the distance between the two numbers on a number line. So let's kind of summarize that, right? Distance and subtraction. If a and b are two numbers on the number line, then both the absolute value of a minus b and the absolute value of b minus a will give the distance between the numbers. Now, it's probably pretty straightforward when you have numbers like 5 and 16, because you can just look at that and go, yeah, sure, 16 minus 5 is 11, great, the distance is 11. It gets more complicated when negative numbers start to show up. So let's look at our first example that involves negative numbers, exercise number 2. The points are plotted at -3 and 6 on the number line below. Answer the following questions. Find the following two differences and verify that their absolute value gives the distance between the 2 points. All right, so let's talk about this a little bit, right? So we've got these two numbers. One of them is sitting at -3, one of them sitting at +6, all right? And my claim is that we can either do 6 minus -3 or -3 minus 6. Once we find their absolute value, that will then tell us how far apart they are on the number line. Now for a moment, don't worry about distance. What I want you to do is pause the video now and just figure out what the result of both of these calculations are. Go ahead and take a moment to do that. All right, well, if you recall, we can change any subtraction into an addition by its opposite. So 6 minus -3 is going to be the same as 6 plus 3, which is going to be 9. -3 minus 6, you can think about that as -3 plus -6, and that's equal to -9. In both cases, their absolute value is equal to 9. So the absolute value of 9 is equal to 9, and the absolute value of -9 is equal to 9. Right? And in fact, now let's verify, right? When we look at this picture, it's pretty easy to tell that the distance is 9 because we have 3 units here, we have 6 units here, and when we add them together, the distance between them is 9 units. Now again, I know, right, that many of you probably would look at this and just go, hey, look, man, I can see the -3, I can see the 6, that's going to be 3 units, that's going to be 6 units, the distance between them is going to be 9 units. And certainly, if the question is just simply how far apart are these two numbers on a number line, and you thought about it that way, that would be fantastic. There'd be nothing wrong about that at all. But we want you to know that when you subtract two numbers and then find the absolute value of that difference, it will tell us how far the two numbers are apart on a number line. So let's get some practice with that in the next exercise. Here we go. Lots and lots of examples. Exercise number 3. In each of the following, two numbers are given. Find the distance between the two numbers using subtraction and absolute value. Show your work. All right, so let's talk about this. Now, before we even jump into this, let's be very clear, right? Whenever you subtract two numbers, your result either is positive, negative, or 0. The only way, of course, it's going to be 0 is if the two numbers are the same. The way it's going to be positive is if you have the larger number, or the greater number, I should say it that way, the greater number minus the lesser number. But the key here is that we should be able to do the subtraction in either order. As long as we then find the absolute value, it will give us the distance. So what I'm going to do in every single one of these examples is I'm going to always, for me, I'm going to always just take the first number, I'm going to subtract the second number, and I'm going to find their absolute value. So in letter A, I'm going to simply say that the distance is equal to the absolute value of 72 minus 25. Now 72 minus 25, all right, if you need to, you could always come over here and kind of do that subtraction. You might not need to do this, but you might need to do it. And that's completely okay, right? So we would find that would be the absolute value of 47, which is just equal to 47. Now, let me just look at something really quick. We've got 72 minus, 72 minus 25. Yeah, that's right, because we would end up having 55, no. Why is this not working? 4, no, that's right. That's right. Yeah. So we've got a distance of 47. All right. Now again, we could have done the absolute value of 25 minus 72. We would have then gotten negative 47 in the absolute value, but then after finding the absolute value, we would have had positive 47. All right. At the end of the day, though, that's it, right? All we have to do is find the subtraction, find the difference, find its absolute value, and that'll be the distance between the numbers. With two numbers that are positive, it should be a piece of cake. What starts to get very confusing is when we have a positive and a negative, or when we have decimals or fractions, etc. So let's take a look at letter B, where we have the numbers 24 and negative 17, and we want to know the distance between them. All right, so again, I'm just going to automatically do something like this. I've got the absolute value of 24 minus negative 17. Notice how I put that negative 17 in parentheses just to kind of help me think about it a little bit. Whenever we subtract a number, we can always think about it as adding the opposite, so I can turn that into 24 plus 17. 24 plus 17 ends up being 41, so we end up having the absolute value of 41, which again is just 41. All right, nice and easy. And at this point, again, you might be saying, I don't really see the point of the absolute value bars because it seems like when I get to this point, all I'm doing is taking the number in there and rewriting it down. And that's because that difference that we keep getting ends up being positive. Let's take a look, though, at letter C. This is where it can get quite confusing. Here we've got two negative numbers, and I want to find the distance between them. All right? So, again, I've got the absolute value of negative 18 minus negative 2. I want to find the difference between those two numbers. Right? Again, when I've got a subtraction of a negative, it's probably most convenient to add the opposite. And now if I've got negative 18 plus positive 2, I'll get a little cancellation there, and I'll get negative 16. Find its absolute value, and the distance between them is positive 16. And again, I bet that that makes a lot of sense. I mean, if the distance between 2 and 18 is 16, then the difference also between negative 2 and negative 18 is 16. Distance is always a positive number, except in the rare case when the distance is 0. 0 is neither positive nor negative. All right, why don't you try letter D on your own, and then we'll do a little bit of work with fractions and decimals together. All right, let's do it. The distance between negative 16 and 27. Here we go. I'm going to find the absolute value of their difference. So I'm going to have negative 16 minus 27. If that's difficult to think about, then it's always okay to add the opposite. And I kind of like that in this case because now we have negative 16 plus negative 27. And if I've got negative 16 plus negative 27, I get negative 43, whose absolute value or distance is positive 43. All right, so the distance between a negative 16 and a positive 27 is a positive 43. All right, let's take a look at a little decimal and fraction work. Now again, one of the unfortunate things about decimals and fractions is that we have to deal with them. There are many cases in life where we need to measure quantities in terms of decimals and in terms of fractions. And those numbers can obviously be plotted on number lines, which means that we can find the distance between them. So in letter E, we want to know the distance between negative 4.57 and negative 1.36. This might be the most challenging one that we've got up here, but let's work it out together, write down the formula, and see how it all works out. Again, just starting, all I'm going to do is I'm going to say, well, that's going to be negative 4.57 minus negative 1.36. Ah, that's a little ugly. All right, so I'm going to change that subtraction of a negative into a positive. And again, let's kind of step back for a second and take a look at this. This could be challenging just to think about, right? How do we think about it? Now, one thing that I know is that when I add this negative number and this positive number, the result will be negative. Then I'll take the absolute value and I'll get a positive. But ultimately speaking, just the thing inside of here should be negative because I have a greater absolute value here than I have here. So if I want to find the net result of this, remember what I'll do is okay, I know the answer is negative, but how much will kind of cancel between this positive and this negative? I actually kind of do that with subtraction. Maybe over on the side of my sheet, I take 4.57 and subtract 1.36, and I'll have 3.21. So this would be the absolute value of negative 3.21, which gives me a distance of just positive 3.21. All right. And fractions. Fractions. Why don't you take a shot at letter F on your own? See what you can remember about subtracting and adding fractions, and then we'll go through it. Oh, so unfair. I had you do the fraction one on your own. But let's take a look. It's not too bad. Again, we're just going to have 11/6. That's not an 11, that's a 16. How about 11/6 minus negative 7/3? All right. But I'm going to change that subtraction of a negative into adding a positive. So I'm going to have 11/6 plus 7/3. And of course, I can only add two fractions if they have a common denominator, whether they're inside of an absolute value bar or not, doesn't matter. I can do that by multiplying that second fraction, the top and the bottom, by 2. So that would be 14/6 as an equivalent. So that's going to be the absolute value of 25/6. Since 25/6 is positive anyway, its absolute value is the same. So we'll just leave it like that. You could, of course, also write it as a mixed number, and that would be 4 and 1/6. The directions are not clear about whether or not we should specify an improper fraction as a mixed number, so either one of them should be acceptable as a final answer. All right, but that's it. The distance between two numbers on a one-dimensional number line, whether it's horizontal or vertical, can always be found by finding their difference, subtracting them in either direction. Sometimes you'll get a positive, sometimes you'll get a negative, and then finding the absolute value, which will always leave you with that positive distance. Let's take a look at an applied example for our last problem. Here we go, exercise number 4. A roadster and a sports car are having a long-distance race. Since the sports car is naturally faster than the roadster, it starts at a position of negative 12 miles, and the roadster starts at a position of positive 18 miles. First part of the problem asks us to set up an expression that calculates the distance that initially separates the two cars. Evaluate this expression. All right, so it's kind of perfect, right? We can almost think about like the 0 mark as being the starting line, right? And it's sort of like we're giving the roadster a head start of 18 miles, and the sports car, we're kind of like putting it 12 miles before, right, where we've located 0 on our number line. So if we want to know the distance between these cars, we can use a subtraction problem. Why don't you go ahead, set that subtraction problem up with absolute value to find the distance between the two cars. All right, simple enough. We can do 18 minus negative 12, or we can do negative 12 minus 18. It really makes no difference. So let's do negative 12 minus 18, right? Because here we've got one at negative 12, right? Here we've got the other car at positive 18, if you will. So that's the absolute value of negative 12 plus negative 18. Negative 12 plus negative 18 is a total of negative 30. Take its absolute value, and they are separated here. We can use units by 30 miles. And again, that's probably pretty obvious, right? This thing is 12 miles before 0. This thing is 18 miles after 0. So they're a total of 30 miles apart. Pretty simple. Let's take a look at the last part of this problem, which doesn't have so much to do with distance, but it has to do with speed. If the sports car travels 10 miles per hour faster than the roadster, how many hours will it take it to catch up? All right, this is just some kind of logic reasoning about speeds, distances, and times, right? Keep in mind that, right, the sports car starts 30 miles before the roadster, and yet it's going 10 miles per hour faster. Pause the video now and think about how much time it's going to take for it to catch up. All right, well, it's pretty simple. I hope you said 3 hours, because the plain fact is, if 30 miles separates them, right, and the sports car is traveling 10 miles per hour faster, I mean, Who knows, maybe the Roadster is just sitting still and the sports car is traveling at 10 miles per hour, right? In which case, since it's going 10 miles per hour faster, it will simply take 30 miles divided by 10 miles per hour, and that will give us, it's my Phantom Red. I haven't seen that for a little while. That will give us 3 hours. All right, pretty simple. Let's summarize the lesson. All right, or let's go this direction. Nope, how about this direction? One of those directions, who knows? All right, so the plain fact is what we saw today was pretty simple. If we've got two numbers on a number line, doesn't matter if they're both positive, both negative, one's negative, one positive, doesn't matter. If we want to know how far those two numbers are apart, we're going to subtract the two. Now, the problem with subtraction is that subtraction, the order matters. In one case, when you subtract two numbers, you'll get a positive answer. In the other case, you'll get exactly the same answer, but it'll be the negative version. Once we take the absolute value of that result, regardless of the order we do the subtraction in, we will then know the distance that separates the 2 points on the number line. This is an extremely important idea about subtraction and what it tells us about sort of our physical world. All right? And we'll be using it a lot in future lessons. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.